As part of this session, let's learn why Golang. Why Golang is required. There are other languages like C++, Java already there in the market. Let's learn more details about why Golang is more important than other languages, and also this support from Google. Why Google supporting this language? Let's talk about why Go or Golang. Let's take a step back and see what are the problems we have currently. So we'll talk about hardware limitations like Moore's law. What is Moore's law? Moore's law says that number of transistors on a microchip doubles every 2 years, though the cost of computers is off. Growth of microprocessors is exponential. If you observe this trend on microprocessors, transistors related stuff, the single thread performance and the frequency of the processor remained steady for almost 10 years, right? So if you are thinking that adding more transistors is the solution, then that is wrong. This is because at smaller scale, some quantum properties start to emerge because it costs more to put more transistors. What are thoughts we have to improve the performance? Manufacturers started adding more and more cores to the processor, introduced hyper threading, added a more cache to the processor to increase the performance. It has its own limitations again. Adding more cores to the processor has its own cost too. We cannot add more and more cache to the processor to increase the performance as cache have physical limits. The bigger the cache, the slower it gets. So if you can't rely on hardware improvement, the only option is to write a more efficient software to increase the performance. Let's say like modern programming languages like C++ and Java from the 19th single-threaded environment. Most of these programming languages support multi-threading, but the real problem comes with the concurrent execution, threading and locking, race conditions, and deadlock related stuff. These things make it hard to create multi-threading applications in those languages. So hardware manufacturers adding more and more cores to the processors to increase the performance. But the software we develop and the programming language should support concurrency easily, and they should be scalable with increased number of cores. Basically, we need to utilize the more cores efficiently. So coming to C++, creating a thread is not memory efficient, as every thread consumes approximately 1 MB of memory, even though you are using or not using. If you start spinning like thousands of threads, they will put tremendous pressure on the heap and will cause shutdown due to the out of memory. Also, if you want to communicate between two or more threads, it's very difficult and high latency. So threads has its own states basically, like a ready state, running state, sleeping, dead, suspend. It is again moving from one state to another state is kind of again like time consuming things. So coming to Golang, Go is like very simple, faster development, compiled language and is a clean coding. It also has the garbage collector, like automatic memory management is available, and it is scalable, and which is actually one time you write the code and you can do the cross compiling for Windows, Mac, and Linux. Let us talk more about Golang, how it came like that. So Golang developed by at Google in 2007, and first release was like 2009. When first release was released, at that time multi-core processors were already available in the market. So Go is built keeping concurrency in mind, and Go has Go routines instead of threads. So as we discussed in C++ threads, it consumes 1 MB of memory, heap memory, even if you are using or not using. But the Go routine starts with 2 KB. It's very simple, very small. So, and you can run millions of Go routines at any time, but you can't run thousands of threads. It will go out of memory. So Go routines actually global segmented stacks. That means they will grow memory when they need it, and come with a built-in primitive communication safety between themselves, like the primitive types called the channels, and it's a faster startup time than threads because threads has a state second like start, resume, or running like that. But Go routine is nothing, just it will just start like that. And Go routines and the OS threads do not have one-to-one mapping. A single Go routine can run on like multiple threads. Go routines are multiplex into smaller number of OS threads. Allow you to avoid having the resort of multi-lacking when sharing data between the structures. Concurrency is about dealing with a lot of things at once. Parallelism about doing a lot of things at once. Go brings best of both the worlds like low level and high level. Like low level languages like C, C++, Go is compiled language. That means performance is almost near to the low level language. It also uses garbage collection to allocation and removal of the objects.